All right, well, it should be Wednesday at this point. We're going to go over section 2.1 and then we're going to start section 2.2. I should have passed out the guided notes. Make sure you have those to kind of just help you organize everything. As you see from the slide here, we're going to deal about with distance and midpoint. We'll do the basics and then we'll do a couple other problems with those. All right, the distance formula in the coordinate plane. Just as you remember, the distance between 2 points, which will denote P and Q, is given by the following formula: x2 minus x1 quantity squared plus y2 minus y1 quantity squared, where we take the square root of the whole thing. Well, this is basically rooted in the Pythagorean theorem. If these are just our two general points here, this is being P and this being Q, if you form a right triangle, the distance is this hypotenuse. Well, the horizontal leg will be the differences between the x coordinates, x1 and x2, or x2 minus x1. The vertical leg will be the distance, the y coordinates, y2 minus y1. So you can figure out your horizontal length, you can figure out your vertical length, those sides of the triangle, and using a squared plus b squared equals c squared, you can get the distance. But we can do this without drawing everything out, just by using the distance formula. So to find the distance between the points P, -2, 5, and Q, 3, -4, if you want to, we'll label this x1, y1. We'll label this one x2, y2. And distance, square root, x2 minus x1 quantity squared plus y2 minus y1 quantity squared. X2 being 3. You're always subtracting, so it's minus -2 squared plus y2, which is -4, minus 5 quantity squared. And we get distance equals the square root. 3 minus -2 is +5 squared plus -4 minus 5 is -9 squared. And that will be 25 plus 81. And so we get the square root of 106. You do want to simplify that if that's possible. 106, though, is just 2 times 53. It does not reduce. A lot of times this is fine. If you need a decimal answer, then obviously you just use your calculator. Square root of 106, approximately 10.3. And that's just your basic distance between 2 points. Follow your formula. Midpoint formula. All right, given 2 points, P and Q, we want to find the halfway point. Well, in order to do that, we just take your x coordinates, add your x coordinates together, divide by half. You're just taking the average of the x's. It has to be halfway in between there. Same thing with the y's, it's going to be halfway in between there. If you want to think again a little bit on the same lines, oops, we don't use the Pythagorean theorem, but we want to be halfway in between the x values. We want to be halfway in between the y values. That'll give us our midpoint. Now, it's a point, not a distance. So you got to write it as an ordered pair. All right, find the midpoint of the line segment joining the points -3, 6, and 1, 4. So the midpoint is the average of the x's, x1 plus x2 divided by 2, y1 plus y2 divided by 2, and that will give me -3 plus 1 over 2, comma, 6 plus 4 over 2, -2 divided by 2 should be -1, and 6 plus 4 is 10. 10 divided by 2 is 5. So your midpoint, ordered pair, -1, comma, 5. All right. Now this problem isn't as straightforward. All right, find x such that the point x comma 2 is 5 units from 3 negative 2. I'm not sure if this is drawn out on your paper or not. It may not be, but drawings sometimes help to just understand what's going on. Here's the point 3 negative 2. I need a point that is 5 units away. Well, if I go straight up, 1, 2, 3, 4, 5, that's 5 units away, but that can't be the point because it has a y coordinate of 3. The point that we're looking for has to have a y coordinate of 2, which means it has to fall somewhere on that blue line, because that blue line will have a y coordinate of 2. Now, we don't know where at this point, and it doesn't have to, obviously it's not going to be vertical. Okay, it's going to be at an angle. Well, we want to find the distance. And I'm just going to put this here. And we want this distance to be 5. We want that distance to be 5. Well, this point here is 3 negative 2. I don't know what this point is going to be, but I do know that it has to have a y coordinate of 2. We'll just use the distance formula and what we have here, and I can plug in 5 for d. So distance equals square root x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Well, we know the distance. We want the distance to be 5. So put that in there. All right, now I'm going to subtract. I'm going to go ahead and start with, let this one be my x2, y2. And I'm going to do x minus 3 squared plus 2 minus negative 2 quantity squared. So 5 will equal, and I'm going to do some simplifying here, x minus 3 quantity squared plus, well, this is going to be 2 minus negative 2, which is going to be 4, and we're squaring it. It's going to be 16. All right, well, at this point, I got to solve for x. I got to get rid of this radical. So we need to square both sides. I'm going to square this side. I'm going to square this side. And when I do that, I get 25 equals, and now you're just left with x minus 3 quantity squared plus 16. All right, FOIL. And so I'm going to get 25 equals x squared minus 6x plus 9 plus 16. And I get 25 equals x squared minus 6x plus 25. All right, since I do have an x squared, I'm going to set it equal to 0. Subtract 25. I get 0 equals x squared minus 6x. All right, so I can factor this into x times x minus 6, and I get x equals 0, and I get x equals 6. So you actually get two answers. If you get two answers, because I'm going to go back here, and so that means we're going to have 2 points. The first point is going to be 0, 2. We're finding the x value. The y value is always 2. And another point is going to be 6, 2. When we look at it, 0, 2 will be right there. That distance, oops, it's not very straight, will be 5. And the same thing here. You're going to get 2 points that will yield a distance of 5. Basically, you got a isosceles triangle. All right. All right, so we got our 2 points and we got our 2 distances, and that can happen in this case. All right, let's take a look at another example here. It says find the point on the x-axis that is equidistant Equidistant means the same distance, okay? From the points -3, 6 and 8, 3. Here's -3, 6. Here's 8, 3. Make sure you read through these types of problems because sometimes the axis will switch. Sometimes they'll say the x-axis, sometimes they'll say the y-axis, and that'll switch a little bit how you do the problem. All right, if it's on the x-axis, it has to be somewhere on here. I want it to be the same distance from those 2 points. Well, I'm just going to give a rough estimate, and hopefully it makes sense that this distance here and this distance we need to find that are the same. I'm going to call this one D1. I'm going to call this one D2. So we want D1, distance 1 to equal distance 2. All right, well, the distance formula is going to be involved. This is the point -3, 6. This is the point 8, 3. And this is going to be the point x0. Since it's on the x-axis, it has to have a y-coordinate of 0. Well, what I'm going to do is just set the distance formula up for D1. I'm going to set the distance formula for D2 and set those equal to each other. So for D sub 1, I'm going to take x minus -3 quantity squared plus 0 minus 6 quantity squared. So that's D1. That has to equal D2, which I'm going to use as x minus 8 quantity squared plus y minus, or no, 0 minus 3 quantity squared. Well, I want to get rid of well, let me simplify just a little bit, and then we'll get rid of the radical. Make this look a little bit nicer. That's going to be x plus 3 squared. That's going to be a -6 squared, so it's going to be plus 36. And then this is going to be x minus 8 quantity squared, and that's going to be a -3 squared, which is plus 9. And then I'm going to square both sides. And then, so that's going to give me x plus 3 squared plus 36 equals x minus 8 quantity squared plus 9. And then that gives me x squared, FOIL there, plus 6x plus 9 plus 36 equals FOIL here, x squared. I'll end up with what? Minus 16x plus 64 plus 9. All right, just simplifying over there. X squared plus 6x plus 45 equals x squared minus 16x plus 73. Well, one good thing we notice here, we do have an x squared on each side, but since it's just an x squared, if I subtract x squared, that will cancel out, and it just leaves me 6x plus 45 equals -16x plus 73. Now I just got a linear equation. Get x by itself, add 16x, add 16x. I get 22x plus 45 equals 73. Subtract 45, and I get 22x equals 28. Divide by 22, and that gives me x equals 28 over 22, which I'm going to reduce to 14 over 11. That's fine. I don't need to write it as a decimal. All right, so it says, go back to the top here. All right, find the point on the x-axis. We found the x-coordinate, so it's going to be 14/11, comma 0. So it's going to be a little bit more than 1. So that was somewhat close on there. And this is one you're not going to be able to just guess at. You know, you could say 1 or 2 or 1.5, but to get it exact, you're going to have to go through the steps here. All right, so that's using your distance formula. You got to be careful when you're reading a problem. Watch what axis they want to be equidistant from. In this case here, it's the x-axis. Like I said, sometimes it's the y-axis. Okay, that was section 2.1. There's not a lot to it. Those problems, those last two, are kind of the tougher ones of the section. Other than that, it's mostly just finding distance and midpoint. And when we get into section 2.2, graphs of equation. All right. It says, without using the graphing capabilities of your calculator, sketch a graph of the following function. Well, when you're asked to graph, and you just can't type this in your calculator, you want to plot points. Well, I think it's been ingrained since probably Algebra 1, if not before, that I think the vast majority of you are just going to plot -2, -1, 0, and 1 and 2. You're just going to pick those points and plug those in. Well, if I plug those in, let's see what I get here. -2 squared is -8. I might as well just use my calculator. And -2 cubed plus 4 times -2 squared. Okay, gives me 8. So you get the point -2, 8. All right, if I plug in -1, that gives me -1. That gives me +4. -1 plus 4, it looks like it's 3. When you plug in 0, I get back 0. When I plug in 1, that's a 1. 1 cubed is 1. That's a 4. 1 plus 4 is 5. And if I plug in 2, 2 cubed is 8. 2 squared is 4. 16 plus 8 looks like it's 24. All right, well, if I just let these be ones here just for now, -2, 8 would be here. -1, 3, 0, 0, 1, 5. And then 224 is way up here. Probably a little bit higher up, but you get the idea. All right, so just from those points, initially you might just want to go, oh, if I connect those, okay, it looks something like this. Well, I'm going to go to my calculator, and I am actually going to graph it. And I'm going to graph x to the third plus 4x squared. And I'm going to hit graph. Whoops. Let me change my window. And I'm going to go zoom 6. All right, there's the actual graph. Now, I'm sure many of you would have figured out it's a cube, so there's got to be more going on than just what I see here. But when you plug in -2, -1, 0, 1, and 2, that's rarely, as we move up in math, going to be enough to figure out exactly what's going on. So what do you do if you can't just plug it in your calculator? What you got to do is you got to plot more points. Okay, the more points plotted, the more accurate the graph. So if you're not sure what's going on, you can pick extra points and plot those. We're also going to find other key points as we move on, but in anything, we're going to plot points. The graph of an equation is basically a geometric picture of its solution set. You can always sketch a graph by plotting points like we just went over, and the more points plotted, the more accurate the graph. Well, we want to figure out what these key points are. So some important points on a graph are the x and y intercepts. Well, just looking at this figure, x-intercepts are where they hit the x-axis. So right here, the x-intercept is -2, 0. This x-intercept is 3, 0. It does have a y-intercept. The y-intercept is 0, 9. If hopefully you recall, but here's the procedure to find the intercepts of a graph. Let me make this bigger. Okay, to find the x-intercepts, which are these, you set y equal to 0 and solve for x, because the x-intercept, the y-coordinate will always be 0. To find the y-intercepts, you set x equals 0 and solve for y, because the x-coordinate will always be 0. And that's basically your algebraic rules for finding x and y intercepts. Sometimes you can find, you have enough knowledge about the equation that you can figure them out. But when you can't, you use these procedures. All right, find the x and y intercepts for these following problems. 5x minus 2y equals negative 30. Okay, so basically what's going on for the x-intercept, let y equal 0. So I get 5x minus 2 times 0 equals negative 30. That just reduces to 5x equals negative 30 divided by 5, x equals negative 6. Now I do want you to write these as ordered pairs. That's negative 6, 0. Y-intercept, let x equal 0. So I got 5x minus 2y equals negative 30. You're going to take the x out, plug in 0. Negative 2y equals negative 30. Divide by negative 2, I get 15. So I get 0, comma 15. Well, if you remember, this is 5x minus 2y. You got no squares, you got no exponents. This is a linear equation. This is a linear graph. And for this, the x and y intercepts, here's 0, 15, negative 6, 0. That essentially gives us enough to give us a pretty good idea what that graph's going to look like. Okay, when we sketch it, that's a negative 6, 0. So those are important points. They give us a good idea what's happening with that linear graph. All right, the second one. Y equals x squared plus 3x plus 4x plus 3. So we look forward, we find first up here, x-intercept. X-intercept. Let y equal 0. So that's going to become 0 equals x squared plus 4x plus 3. Well, we're left with a quadratic. That didn't happen last time. So that's a lot of why some of the reason we spend some time solving quadratics in the last chapter is we need to solve that. And this is factorable into x plus 3, x plus 1. So x equals negative 3, x equals negative 1. So this has two x-intercepts, negative 3, 0, negative 1, 0. For the y-intercept, let x equal 0. So you get y equals 0 squared plus 4 times 0 plus 3. Well, that all wipes out, washes out. You're just left with y equals 3. So I'm left with the 0.03. Well, those are important points. So I got negative 3, 0. I got negative 1, 0. And then I got 0, 3. Well, if you recognize you have a quadratic, it's going to be parabolic in shape. It's got to go through those 2 points, and it's got to hit there. I probably didn't draw that very good. But this gives you at least some type of idea what it's going to look like. It's got to hit those 3 points. You remember, as a positive x squared, it's got to open up. So x and y intercepts are very useful when graphing. And, all right, what's going on here? All right, this is not going anywhere, so let me pause this for a second, see if I can figure this out. Hold on. All right, we're back, and I think we got it somewhat fixed. All right, last one. Find the x and y intercepts. And let's see here. Y-intercept, let x equal 0. And so that's going to be 0 squared plus y squared equals 9. That's y squared equals 9. You're going to take the square root, but you're going to do plus or minus. So you're going to get y equals plus or minus 3. So you're going to get two y-intercepts, 0, 3, 0, negative 3. X-intercept, let y equal 0. I get x squared plus 0 squared equals 9. X squared equals 9. We're going to take the square root. and I get x equals plus or minus 3. So that's going to be 3 comma 0 and negative 3, 0. All right, well, what do we got here? What do we have? And if I plot those, these are the 4 points where they intersect. Now, it's probably been a while. You may not recognize it by just looking at it. Maybe you have, but this is going to be a circle. Oh, that's a bad circle. But that's a circle, or that graph is of a circle. So finding the x and y intercepts give us some of the key points that are going to allow us to graph. And that's a little bit of what we're going to do in section 2.2, find some key things that help us to graph. All right, that's the end of this lesson. We did 2.1 and 2.2. Here's your homework. 61 can be a little bit tricky. Just asking you to verify something. Think Pythagorean theorem. I'll just give you that clue. Okay, it'll come up twice. But go ahead and get to work on those, and then hopefully I'll have your tests back to you on Thursday.